Eighth graders, this is to help you with question 3 on CR 30. It says function 1 is represented by the equation y equals negative 3x plus 2. And function 2 is represented by the graph below. So this right here is function 2. And I just blew up the graph over here. For which function are all the output values less than 2? Okay, less than negative 2, sorry. Output values, they're talking about the y values. So let's go ahead and on this grid graph this. Let's look at function 1. Y equals negative 3x plus 2. So this is in the form of a straight line. And I think if I graph it would be the easiest way to tell whether all of the y values for this straight line are less than negative 2. So here I can tell you my slope is negative 3 and my y-intercept is 2. My slope is negative 3. So if you have a slope of negative 3, we write that as negative 3 over 1. And that means from the y-intercept, I'll move down 3 and always over to the right, right 1. If it's a negative slope, I move down and to the right. Had it been a positive slope, I'd move up and to the right. Okay, so the first step in graphing this, I'm going to plot my y-intercept. So there's my y-intercept. And from the y-intercept, I'm using my slope. I'm going to go down 1, 2, 3 to the right 1. Down 1, 2, down, sorry, 1, 2, 3 to the right 1. If I'm moving down 3 to the right 1, I could also move up 3, 1, 2, 3, but now to the left 1. And that, my line is not beautiful. Because I don't have a ruler, because I'm just drawing across the screen. Oh my God, how ugly is that line? Oh well. Okay. Sorry about that. That's the line y equals negative 3x plus 2. That's function 1. Let's just go ahead and look at some points on function 1. This point right here is negative 1, 1, 2, 3, 4, 5. Negative 1, 5. This point right here is 0, 2. I'm just picking out some nice points. This point right here is 1, negative 1. And this point right here is 2, negative 4. And the question is, are all of the y values less than 2? So for function 1, we can call them input. Oh my gosh, output. Sorry, my lines are terrible. So if I had an input value of negative 1, because input is x, output is y. If I have an input value of negative 1, the output is 5. If I have an input value of 0, the output is 2. If I have an input value of 1, the output is negative 1. If I have an input value of 2, the output is negative 4. I'm going to tell you some of the outputs, some of the y values are less than negative 2, but 2 is definitely bigger than negative 2. 5 is definitely bigger than negative 2. So it's not function 1. Let's take a look at some of the points for function 2. Here's one of the points. This is 0, negative 3. This right here looks like negative 1, negative 4. This point right here looks like positive 1, negative 4, and that graph's just going to keep on going down. It's not going to be up in the positives up there at all. So if I look at this as function 2, lots going on here. If I make a table for function 2, and I do my x and y values, I have to tell you, I am so sorry. This is like a mess. So I have an x value of 0. My y value is negative 3. If I have an x value of negative 1, my y value is negative 4. If I have an x value of positive 1, my y value is negative 4. Hey, look at all our y values. Negative 3, negative 4, negative 4. And they're just going to keep going down. So I have to tell you this is function 2. I can see that right from the graph, or I look here at the output values in a table. Ooh, I'm not loving that video, but it is what it is. I hope that helps some.